All right, we got another standard-based quiz coming up, this one on stoichiometry. You can watch this video prior to your first attempt or when you're trying to figure out where you went off track after you've taken the quiz. So make sure you have good notes while you're taking it. Sometimes we'll be able to show you the questions, other times we will not. So you want to always start with that known equals question mark unknown so that you can work on it on your own time later on. And it's just good to get in the habit of writing out your work all the time, even though it's virtual, because at some point it's going to be good for you to have that system down. Okay, now read the assignment carefully because some standard-based quizzes are going to have attempts and some aren't. Some are going to have test corrections and some aren't. And some are just going to be one attempt and that's it, one and done. So read so you know how you need to maximize your item. Okay, so here's our first one. A teacher reacts 92.30 grams of hydrochloric acid. So right off the bat, I know on my paper, I'm going to write 92.3 grams of hydrochloric acid. And since I also know I need to write the balanced chemical reaction, because if I'm doing stoic, I always need a balanced chemical reaction. I'm just going to go ahead and write the balanced chemical reaction and my knowns right above it. So 92.30 grams of hydrochloric acid with excess magnesium hydroxide, excess. You see excess there, oftentimes it's not a limiting reactant. So that is always nice. There's no number for magnesium hydroxide. So I'm not going to need to start that off as a known. According to the reaction above, if 50 grams of magnesium chloride are produced, okay, so this is not my stoic, I'm going to have to stoic to magnesium chloride, but 50.0 grams is my actual yield because this is what was actually produced in the experiment. So that's just the indication that the product that I need to stoic to is magnesium chloride because the product, magnesium chloride, has the yield associated with it. So in this case, I'm only going to need one stoic because I only have one known with information. And I'm going to stoic to the product of the yield. My known 92.30 grams of hydrochloric acid equals my grams of magnesium chloride. When you're writing these statements out, your magnitude is your number, your units is your grams, your species is hydrochloric acid or hydrogen monochloride would be another way of saying that name if it's in its covalent form and not its acid form. Okay. And if we haven't done acids yet, don't worry, we'll go over that later. And then after the question mark, you're going to have units and a species as well. So when you're setting up your known equals question mark unknown, this is what you should see each time: a magnitude, unit, species on the left, a question mark, unit, species on the right. So that was my known equals question mark unknown. And there it is, a little bit drawn out that way. So there is our box. Step one is done. Now we're going to go to step two. Step two, we need the pathway. So I look at the units of the known and the units of the unknown. I'm going from grams to grams. So my pathway is grams to grams. So I have my little mole map here. And I am going to start over here with mass because that is the units grams. And I'm going to go to mass over here. I need to stay on the roadway. So I'm going to go from mass to moles. That's moles of the known because he's on the left side. And then I'm going to go from moles of the known to moles of the unknown. Moles of the unknown because he's on the right side. He has to be the unknown. And then moles of the unknown to the mass. So I have three arrows. So I'm going to have 3 unit conversions. My first unit conversion is molar mass. My second unit conversion is mole ratio. My third unit conversion is molar mass. So every single time, set up the entire problem so that you have it. Okay. How do we do this? We always start and then we times it times unit conversion 1 times unit conversion 2 times unit conversion 3. Okay. So those are all fractions. I'm going to have 4 total fractions that I'm multiplying. My start fraction is always known over 1. My unit conversion number 1 is molar mass. Does it go in the numerator or denominator? Divide, so it's under the divisor. Molar mass of the known goes in the denominator. A 1 goes in the top. Why? Because 1 mole is equal to the molar mass. So I have to have the equivalent. 1 mole is on the top, molar mass is on the bottom. So when you're doing these problems, you're really taking your start number and you're multiplying it times 1. So I'm going to multiply it times 1 3 times. But I get a different answer. Why? Because I changed my units. And because it's stoic, I changed my species. So known over 1 to start. So I have that first one done. Unit conversion number 1 was divide by molar mass. Unit conversion number 2 is mole ratio. Mole ratio gets written like that, unknown coefficient over known coefficient. Unit conversion number 3 is molar mass again, but it's on the multiply side. So we're multiplying it back in. So it goes in the numerator. It is the unknown's molar mass. Every single time I go from grams to grams, this is my equation set up. Okay. So we have that pathway now established. And then we are going to set up our equation. So I'm just going to rewrite what we had over on the other page. Known over 1 to start. Then the first arrow says divide by molar mass. The second arrow says mole ratio. The third arrow says multiply by molar mass. And that's the molar mass of the unknown, or the first one is the molar mass of the known. That is my equation set up again. So now I can go ahead and start my substituting. My known, 92.3. 92.30 grams of hydrogen or hydrochloric acid. Divide by the molar mass of the known. 36.46 grams of hydrochloric is in 1 mole of hydrochloric. I got those from the periodic table. Hydrogen has a mass of 1.01. Chlorine has a mass of 35.45, and there's only 1 atom of both of them. Unknown coefficient. Who am I solving for? Who got the question mark? Magnesium chloride. So he is our unknown this time. And the coefficients are always the big numbers in front. So my unknown is 1 mole of magnesium chloride. My known is the number we started with. Okay, we started with 92.3 grams of hydrochloric. So my known is hydrochloric. And the coefficient for the known is 2. So 2 moles of hydrochloric acid. The molar mass of the unknown. The unknown is the one we're trying to find, magnesium chloride. Magnesium chloride's molar mass is 24.31 plus 2 times 35.45. And that gives me 95.21 grams of magnesium chloride is equal to 1 mole of magnesium chloride. Canceling. So we did our substituting, but we need to cancel it. Grams of hydrochloric, grams of hydrochloric, moles of hydrochloric, moles of hydrochloric, moles of magnesium chloride, moles of magnesium chloride. I'm going to end up with grams of magnesium chloride. I'm ending up with the units and the species that we talked about at the beginning of the problem. 92.30 times 1 times 1 times 95.21. Where did I get those numbers? 92.30 times 1 times 1 times 95.21. I multiplied all the numerator together and I get 87.883. And my denominator, when I multiply those guys together, 1 times 36.46 times 2 times 1 gives me 72.92. I need the final answer. So 8787.883 divided by 72.92 gives me 120.514029. That is the calculator answer. So that is solved based on the calculator answer. And now I need to do my sig figs. 92.30. Non-zeros are significant. I see the decimal, so that 0 is significant. I have 4 sig figs. Underline the first 4. Why did I underline this 0? Because he's trapped or contained between two numbers, so he is significant. Underline the first 4. So I'm going to be rounding to the tenths. So if the question asks round to the nearest tenth, that's the same thing that I'm doing here. In this particular problem, 4 sig figs gets me the tenth or 1 decimal place. I look next, it's a 1, so this is closest to 120.5 grams of magnesium chloride. That is the theoretical yield. Why? Because that's what the Stoich gives me. The Stoich is always going to give me the theoretical yield, which is 120.5 grams of magnesium chloride. The problem gave me the actual yield because it said produced. So we only were able to produce 50.0 grams of magnesium chloride when we put it on the production line, or actually in this case, the teacher did in the lab. Okay, so now I have to find my percent yield. Percent yield is equal to actual yield over theoretical yield times 100%. 50.0 grams over 120.5 grams times 100%. My grams are going to cancel when you plug it into the calculator. If you get a number over 100%, something is wrong. Go back. You're going to have a number less than 100%. Okay, so 50 divided by 120.5 is 0.41, and I'm going to multiply that times 100. Even though the formula says times 100%, don't put the percent in the calculator. That's just to tell you to add it at the end. 41.5%. That is my percent yield. That is the actual percent produced in this experiment. Okay, and it's under 100%, so I'm feeling pretty good that I did my math right there. And that is the end of that problem. Okay, how about if we have how many molecules of water are produced by the combustion of 1.230 grams of methane? And this time they gave you the equation. Known equals question mark unknown, 1.230 grams of methane. I don't know what methane is because we haven't done the organic unit yet. Okay, but I know this guy is oxygen gas. This is carbon dioxide. This is water. Water has a nice unique name. So I can use the process of elimination. Carbon tetrahydride has an organic name of methane. So CH4 equals how many molecules of water? So now I'm changing substances. So I'm going to need Stoich. I'm going from grams to molecules. So that is my pathway. I look on my mole map. I start with known over 1, and then I divide by the molar mass of the known, and then I multiply by the mole ratio, and then I multiply by Avogadro's number. So if the question is, what is the third unit conversion? That is not the third fraction. Remember, the first arrow is the first unit conversion. So my third unit conversion is Avogadro's number, 6.02 times 10 to the 23rd particles equals 1 mole. My known 1.230 grams of methane divided by the molar mass of methane, 16.05. Let me just put that in the calculator in case I do not have that ending right. 12.01 plus 4 times 1.01, 16.05. Good. Grams CH4 is equal to 1 mole of CH4. Unknown over known. Unknown is water. It has a 2 for its coefficient, 2 moles of water. My known, CH4, there's no number there, so it's a 1. 1 mole of CH4. And then Avogadro's number, 6.02 times 10 to the 23rd. What do I need this time? Molecules equals 1 mole of water. Okay, so since it is a compound of water, then its molecules is equal to 1 mole since we have H2O. All right, so now we plug those answers in. 1.230 times 2 times 6.02 e to the 23rd. That's my numerator. 1.48 times 10 to the 24th is my numerator. I'm dividing it by 16.05 because that's really the only thing in the bottom. And I'm going to get 9.227 times 10 to the 22nd molecules of H2O. And there is your answer for that one. So again, make sure you're doing your known equals question mark unknown very slowly and carefully. There is one problem on there that might not be a stoich. So set up your known equals question mark unknown carefully. If they just wanted 1.230 grams of methane, and how many moles is that? Then that is going to moles of methane, no stoich. So no mole ratio. We are just going from grams of something to moles of something. That is just one arrow, one unit conversion. Want to go from grams to moles, it's divide by molar mass. So it's known over 1, and then we're going from grams to moles. Okay. The known would be 1.230 grams. Okay, and then the molar mass is the same, 16.05 grams in 1 mole. Again, this is only when they want to know how many moles something is. So read carefully. You need the mole ratio if you are converting from one chemical to another. You don't need the mole ratio. You can stop early if they just want what's called a mole conversion. And that is what we did in module 4. So if you want, go back to module 4 and watch a video there if that one is not stuck in your brain, so that you have it for the one question on the formative assessment, if that's the version that you get. How do you get to older modules? In Canvas, click the book that is underneath the dashboard on the left side. Then click all courses. And finally, page down to your last chemistry course, your first semester chemistry course. And then you can go and watch the videos there in the content area. You can watch my live sessions again. Those are all available. And if you can't find those, you can always email me and let me know. And good luck.